You are falling towards something you cannot see. And the worst part is that you didn't notice when it started. There was no alarm, no sudden lurch, no moment where the universe tapped you on the shoulder and said, turn around. 1 second you were drifting in space, engines off, the stars arranged in their usual indifferent pattern around you. And then gradually, so gradually it registered as almost nothing, the stars ahead of you began to bend. Not dramatically, not like a film, just a subtle warping at the edges of your vision. The kind of distortion that makes you think something is wrong with your eyes before you accept that something is wrong with space itself. The light coming from behind you is being pulled forward, lensed around something massive and invisible directly ahead, bending the image of the universe into a ring. You've seen photographs of this effect. You know what it means. You know what is in front of you even though you cannot see it. You cannot see it because it emits nothing. It reflects nothing. It is not a thing that exists in the way things normally exist. It is an absence so total it has gravity. It is a hole in the fabric of what is real, and you are already inside its pull. You have been for longer than you know, and there is not a single law of physics in the entire universe that will let you leave. There is no way out. Before you understand the horror of a black hole, you have to understand what it was. Because black holes don't appear from nothing. They are born from something. From stars, usually stars vastly larger than the sun, stars that have been burning for millions of years with a ferocity so extreme that the light from them could sterilize planets across entire solar systems. For most of their lives, these stars exist in a kind of violent equilibrium, the outward pressure of nuclear fusion, pushing against the inward pull of their own gravity, a balance maintained across millions of years by the continuous detonation of hydrogen into helium at the core. It is one of the most powerful processes in the universe, and it is what makes stars shine, and it holds everything together, right up until it doesn't. When a massive star exhausts its fuel, the fusion stops. The outward pressure disappears in a fraction of a second, and the gravity, which was always there, always waiting, wins instantly and completely. The star collapses inward at a significant fraction of the speed of light. The core is compressed to a point so dense that our mathematics breaks down trying to describe it. And then the outer layers rebound off that collapsing core in the most violent explosion the universe produces, a supernova, an event so bright it can briefly outshine an entire galaxy of hundreds of billions of stars. And what is left at the center, when the light fades, is a singularity, a point of infinite density, a place where space and time, as physical concepts, stop functioning correctly, a black hole. But here's the problem. None of that history protects you from what it has become. Because the star it used to be is gone. What remains has no surface, no heat, no light of its own, just gravity, amplified to a degree so extreme that it warps the geometry of space itself around it. This is not a metaphor. Space near a black hole is literally curved, bent inward, distorted, the way a heavy object distorts a rubber sheet. Except the rubber sheet is the fabric of reality, and the object sitting on it is infinite. The closer you get, the more curved space becomes, and the more curved space becomes, the harder every direction that isn't toward the center becomes to move in. You are not being pulled in the way a magnet pulls iron. You are falling the way everything falls, because the path through space that points away from a black hole gradually and then suddenly stops existing. The boundary where this becomes irrevocable is called the event horizon. It has no physical surface, you cannot touch it, you cannot see it. You would pass through it without feeling it. No wall, no pressure, no alarm, no sensation of any kind. It is simply the radius at which the escape velocity required to leave becomes greater than the speed of light. And since nothing in the universe moves faster than light, crossing the event horizon is a one-way transition with no drama attached to it. The most catastrophic moment of your existence will feel like nothing at all. One moment you are outside, the next moment you are inside. And the difference between those two moments is the difference between a universe in which your future contains possibilities and the universe in which your future contains exactly one destination. And it gets worse. Because inside the event horizon, the nature of time itself changes. In normal space, time flows forward and you can move freely in the 3 dimensions of space. Left, right, forward, backward, up, down. Time is the one thing you cannot reverse, But at least space gives you options. Inside a black hole, those roles exchange. Space, specifically the dimension pointing toward the singularity, becomes the thing you cannot stop moving through. It becomes like time. It flows in one direction only, and that direction is inward, and you cannot stop it any more than you can stop Tuesday from becoming Wednesday. You are not being pulled toward the center. You are falling toward it the way you fall through time, continuously, inevitably, with no mechanism available to you for reversal. Every second that passes inside the event horizon is a second that has moved you physically closer to the singularity. There is no thrust powerful enough to fight this. There is no trajectory that avoids it. The geometry of space inside a black hole has been rearranged so that all paths lead to the same place. And this is where things change. Because a black hole doesn't only destroy what falls into it, it changes the experience of time for everything near it, even outside the event horizon, in ways that are real and measurable and deeply unsettling. Time near a black hole runs slower than time far from one, not as a perception, not as a feeling, but as a physical fact verified by experiment, predicted by general relativity, confirmed by observations of pulsars and orbiting stars. If you were hovering just outside the event horizon of a stellar mass black hole, which would require an almost unimaginable amount of thrust to maintain, and your partner remained at a safe distance and watched you through a telescope, they would see you moving in slow motion. Your heartbeat would appear too slow. Your voice, if you could communicate, would be redshifted into frequencies too low to hear. And if you managed to escape and return to where they waited, you would find that far more time had passed for them than for you. The universe aged around you while you were close to the thing that bends time. This effect, called gravitational time dilation, is not science fiction. GPS satellites have to account for it or they drift out of calibration. It is real. And near a black hole, it becomes so extreme that hovering just above the event horizon for a short period could mean returning to a world that is aged by years or decades or centuries, depending on how close you were and how long you stayed. But that's not even the worst part. The worst part is what the singularity does to matter, to you specifically, if you reach it. In the final moments of your trajectory, as you approach the center, the difference in gravitational pull between your head and your feet becomes measurable, then significant, then lethal. It has a name, tidal forces. Your body, extended across space, is being pulled more strongly on the end closest to the singularity than on the end farthest from it. The difference stretches you. Physicists call this process spaghettification, which is almost a funny word for something so total. You are drawn out into a filament of matter. Atoms still arranged in the sequence that used to be you, stretched across a distance that keeps increasing, pulled apart not by an explosion, but by the inexorable gradient of gravity that grows stronger with every fraction of a meter, closer to infinite density. You are not crushed. You are elongated into something unrecognizable, and then the singularity takes what remains, and at the singularity our physics stops. Our equations produce infinities, our models break. We do not know what happens at the center because the center is a place where the rules that govern everything we know cease to apply. We call it a singularity because it is singular. Outside the reach of our understanding, past the edge of our models, in the territory where the map runs out. In 2019, the Event Horizon Telescope collaboration released the first image of a black hole's shadow. The supermassive black hole at the center of the galaxy M87, 6.5 billion times the mass of the Sun, its event horizon a glowing ring of superheated gas swirling around an absence so total it appeared in the image as a perfect dark circle. Scientists who had worked for years on that image described the moment they first saw it in their data as something that made them fall silent. Not from joy, though there was joy, from something closer to awe. The particular kind of awe that has fear folded inside it. They had taken a photograph of a place from which no photograph could ever be taken. They had seen the edge of the unseeable. In 2022, the same collaboration released an image of Sagittarius A, the supermassive black hole at the center of our own Milky Way, 4 million solar masses sitting at the gravitational heart of the galaxy we live in, around which every star in the night sky orbits, including the Sun, completing one rotation roughly every 230 million years. There is a black hole at the center of our galaxy. There has been since the galaxy formed. Every star you have ever seen from Earth is in orbit around it. The sun, the solar system, the planet you are standing on right now, all of it is circling at an enormous distance, a point in space where time bends and matter disappears, and the laws of physics stop working. We are not near it. We are safe, in the specific sense that an orbit is a kind of controlled falling that never quite arrives. But it is there. It has always been there. And at scales large enough, everything in the observable universe is doing the same thing, circling something heavier, falling towards something denser, caught in the gravity of structures so enormous that the word enormous fails to carry the weight. The universe is full of these things. Stellar mass black holes scattered through every galaxy, supermassive ones anchoring the centers, intermediate ones lurking in clusters, primordial ones possibly seeded through the cosmos since the first moments after the Big Bang. They are not rare. They are not exotic. They are a fundamental feature of how reality is constructed, a consequence written into the physics from the beginning, baked into the rules before the first star ever formed. And the rule they enforce is the simplest, most absolute rule in nature, that there are places you can enter and never leave, that the universe contains one-way doors, that beyond certain thresholds the concept of return is not merely difficult, it is geometrically forbidden. You have been falling this whole time, you just didn't notice when it started.